So this video is just the solution to the 4 parts to this number 6. This is actually from the 2017 exam. It is a non-calculator question. I forgot to put that in, but if you even notice, I think the only thing that you would even try to use a calculator for is working with f of x, but taking the derivative of that is going to be simple enough. So they give us 3 different functions in 3 different ways. F of x here, they're just giving us an actual equation for the function, cosine 2x plus e to the sine of x. G is a differentiable function. The table gives values of g and the derivative g prime at selected values of x. And then h is a function whose graph is given here, and the graph is made up of 5 different line segments. So what's nice about this is it shows us functions in 3 different ways, quite possibly all the ways that we can see it as a table, as a graph, and then just as an equation. It also takes us through, as you're going to see with the different parts, sometimes we're looking at just one function, sometimes we're using a combination of both, and then to find the derivative, sometimes we're just looking at the graph, sometimes it's a derivative rule, maybe the product rule or chain rule. So I'm going to go through each one, showing all the work with explanations, also providing the point values. So please make sure to try this on your own first before you just follow through the steps and keep track of the points as well. Again, as always, let me know if you have any questions along the way. All right, so let's first take a look at A, find the slope of the line tangent to the graph of f at x equals pi. So here we're only dealing with our function f. All right, so we really don't need the table or the graph. I just copied it on every page here. So our function, the slope of the tangent line, is nothing more than f prime of x. And again, f of x was equal to cosine of 2x plus e to the sine of x. So taking this derivative, we're going to use a chain rule again at the cosine of 2x. So it's going to become a negative sine of 2x, then don't forget the times 2, derivative of the inside stuff, plus, and then still the chain rule here, so the derivative of e to the sine of x is e to the sine of x, but then times the derivative of sine x, which is cosine x. So I'm just going to rewrite this first part. This becomes negative 2 sine of 2x, and then you could leave it this way. You could put the cosine x in front, doesn't matter. All right, but now we need to figure this out at x equals pi. So then f prime of pi is going to equal negative 2 times sine of 2 pi plus e to the sine pi times cosine of pi. All right, so sine of 2 pi is going to be 0, so we're getting negative 2 times 0. Sine of pi is also 0, so we'll get e to the 0 times cosine of pi is going to be negative 1. So negative 2 times 0 is just 0. E to the 0 is 1. 1 times negative 1 is negative 1. So there's our final answer for that part. We would end up getting 1 point for the finding f prime of x, so 1 point here, and then 1 point for the answer. So 2 points altogether to finally get to that f prime of pi. All right, for B, let k be a different function, but it's being defined by a composition of h of f of x. We want to find k prime at pi. Now, a lot of times when you're reading these parts, to see all parts together could be a little overwhelming. So I hope by breaking it up and looking at each part individually, reading it a couple of times, and really deciphering what's here could help make the problem become more simple. So k prime of pi, I want to first find k prime of x. And we're using the chain rule for sure here because this is a composition of functions. So it's going to be h prime of f of x times f prime of x. So that's the key to get this part B started here. So now we want k prime of pi, which becomes h prime of f of pi times f prime of pi. F prime of pi we just found on the previous page. So f prime of pi was that negative 1 that we just calculated for part A. F of pi, what we're going to find here, again, remember f of x was just equal to cosine of 2x plus e to the sine of x. So f of pi is going to be cosine of 2 pi plus e to the sine of pi. Cosine of 2 pi is 1. This becomes e to the 0, so we get 1 plus 1, which gives us 2. All right, so now this becomes h prime of 2 times negative 1. For h prime of 2, now we have to go up to the function h of x, which is given to us as the graph here. So h prime of 2, we go over to 2 and look here at this point. I don't want the y value of that. I need the slope of that line segment at that point. So this line segment spans from x equals 0 to x equals 3. But if we're taking a look at the slope, it is a negative 1/3. So this becomes negative 1/3 times negative 1, which gives us a positive 1/3. All right, so we get 2 points for this problem, 1 point for k prime of x, and then 1 point, even though it is quite a bit of work here, just 1 point for determining what k prime of pi is. So between parts A and B, we're up to 4 points, which isn't too bad on a free response question. All right, looking at C, they're giving us another very similar problem here. Let m be the function defined by m of x is equal to g of negative 2x times h of x. We want to find m prime at 2. Well, this is a product here, not a composition of functions. So we're going to need to use the product rule. And we could treat g of negative 2x as u, h of x as v. So remember, we're doing uv prime plus vu prime. So first I want to find m prime of x. I need to use the chain rule when I do find g of negative 2x, but for right now, uv prime is going to stay as g of negative 2x times h prime of x, and then v is h of x times g prime of negative 2x, and then the derivative of the inside stuff will still give us a negative 2. So for this problem, I need to use a combination of the table and the graph. So m prime of 2 will now become, I'm just going to write out every little step, g of negative 2 times 2 times h prime of 2, which we just found in the last part, plus h of 2 times g prime of negative 2 times 2 times that other negative 2. So this really becomes g of negative 4 times h prime of 2 plus h of 2 times g prime of negative 4, and again times negative 2. All right, so g of negative 4, look carefully, we're going to go up to the table. It's g, not g prime, that's first. So g of negative 4 will give us a 5. H prime of 2, which is what we just found in the last table, that was at negative 1/3. Now h of 2, if we go back up to the graph, it might look at first like we have to estimate this, but we could actually figure this out. Because we have this line segment here and we have a slope of negative 1/3, if we were right here at 1, wouldn't we be 1/3 of the way down to the very bottom? So we have the ordered pair here. This would be 1 comma negative 1/3. And then when x is 2, we're 2/3 of the way down. So we have 2 comma negative 2/3. And then once we do hit 3, we're actually that full 1 whole square down. So that would be 3 negative 1. So h of 2 is going to be this negative 2/3. So we have h of 2, again, is negative 2/3. Now g prime of negative 4, so we're going back up to the table, we're looking in the third column, g prime of negative 4 is negative 1. And then times negative 2. So we end up getting negative 5/3. And then over here, we're going to get a negative 4/3 when we multiply those three factors together, giving us a negative 9/3 or a negative 3 for this final answer. And this part of the problem is worth 3 points. I'll just kind of break it down off to the side. We get 2 points for going through the process of using the product rule. So just for that very first step, we get 2 points, and then 1 point for, again, doing what seems to be more work, 1 point for calculating what m prime of 2 is. All right, looking at D, it's asking, is there a number C in the closed interval from -5 to -3 such that G prime of C is equal to -4? We definitely need to justify our answer here. This question, though, hopefully you guys didn't forget. I know it's been a while since we worked with it, but this is taking us back to the mean value theorem if we have a C or at least one C value that exists in a closed interval. But we have to use some facts that leads us, almost like we have to state the hypothesis of the mean value theorem. So in order to lead us to this mean value theorem, which will be our justification, we have to go back to a statement at the very beginning that said G is differential or differentiable on the closed interval. So for G to be differentiable on the interval from -5 to -3, it implies that G will be continuous on the closed interval from -5 to -3. So normally we start saying the hypothesis here is that G has to be continuous on a closed interval and differentiable on an open interval. Therefore, we would say there exists at least one value C in the open interval from -5 to -3 such that G prime of C is going to equal the slope of the secant line. So this is going to become G of -3 minus G of -5 over -3 minus -5. And we're hoping that this slope of the secant line is going to turn out to be that -4. And then we would indicate that this is by the mean value theorem. So we'll put that in up here, very important to include this. So by the mean value theorem, and always write it out when it comes time to taking the AP exam, always write the words out. So by the mean value theorem, there exists at least one value C in this open interval such that G prime of C is equal to the slope of the secant line that connects these endpoints. So just going through the calculation. Again, we're going back to the table. We're looking at the second column here. So G of -3 is going to be 2 minus G of -5 is 10, and -3 minus -5 will give us a 2, so that's -8 over 2, which is -4. So then that definitely works, but we had to, what this problem was really asking us for is to know the hypothesis of the mean value theorem and be able to state that it goes with the mean value theorem, and then join the conclusion here is where we can get to this answer that G prime of C is equal to -4. So this part of the problem was worth 2 points. 1 for calculating the slope of the secant line, and 1 point for the justification using the mean value theorem. So that one might have been a little tricky on how to go about stating everything. But hopefully if you weren't able to get part of this, make sure you finish this or even go back and try it again after you have viewed this video. Just go back. The more you look at it and practice it, the easier the concepts will become. So I am going to post as a separate PDF 2 more free response questions, and this is all I'm assigning today. Tomorrow I'll go over them, and we'll have your test graded as well, and go over a new lesson. I'm going to start another little section. So the slope fields, I have 2 other little sections I want to talk about. That will all be assessed together. So as always, guys, let me know if you have any questions. I'm going to show you a quick sneak peek of the problems, but like I said, I will also post them as a separate PDF so it's easier to view. So this first one, you can use a graphing calculator on. It gives you a table here and has 4 parts to this, so it'll be easier to view the PDF. And then a second question, this is no calculator, quite a bit to read at the very top. Again, this is a problem that you want to just look at each part individually, see what it's asking for. This one only has 3 parts. So hopefully you guys try these. Like I said, I'll show the videos tomorrow. Let me know if you have any questions.